Alright guys, welcome to our channel Code with Sunny, and in this video I will be talking about another good problems of the LeetCode longest consecutive sequence. As the name suggests, we need to find the longest consecutive sequence of some numbers, and the index number is 1 to 8, and the problem is categorized as medium type problem of the LeetCode. Okay, as you can see, I've already given a like over here 537 for it becomes, because this problem is actually an interesting one and we have multiple approaches to solve this problem. So before talking about the multiple approaches to solve this problem, I just want to recommend, if you are unaware about the concept of hash map or hash set, then I think you must have to understand this concept. Also, in my second approach, I will talk about the concept of disjoint set union based data structure. So if you are also unaware about this concept, I will recommend to study that and then come back to my video and understand what I have been doing here to build up the solution in the best possible way. Okay, so without wasting our time, let's discuss this problem. Given an unsorted array of integers, nums, and return the length of longest consecutive element sequence. So we have to return what is the length of longest sequence of elements where the adjacent element holds the difference of exactly equal to 1. We can do this in logarithmic time, or you can say O of n log n time, by sorting the all the elements of this array. It would take a O of n log n time. Best case, then you can just iterate over the array and find out the difference between the adjacent elements. That is, if you sort this array, it would become like 1 2 3 4 100 and 200. You can easily say 1 2 3 4 is exactly equal to the length equal to 4, and this is our answer: maximum length of longest consecutive element sequence. But there is a constraint that is mentioned over this problem. You must write an algorithm that runs in O of n time, that is in linear time. So how we are going to optimize our O of n log n solution time to O of n time? This is going to be like very vital point to understand this in this question. Okay, so I will discuss this problem with the help of examples also. Then we will together build up the multiple approaches to solve this problem. First, I will discuss the unordered set based approach. Then I will come back to the disjoint set union based approach. Okay, both works in almost linear time. Okay, so constraint, talking about the constraint, you can see n's length, that is the num's length, is like 10 power 5. So we must have to consider the solution up to O of n, because here is an constraint also given over here, and the nums of I is going to lies between minus 10 power 9 up to 10 power 9. Okay, you can also see the huge like a huge range of the numbers that it is covering, like minus 10 power 9 to up to 10 power 9, almost int minimum to int maximum. So the elements are not in the range like 1 to 10 power 5. So we must have to think something like different mapping of the numbers to some unique key. I will discuss this over that. If you're not understanding this now, no need to worry about. Let's move further to understand this problem with the help of first examples. Then we will together build up the best solution of this problem. Let's move further. Okay, so you can see over here, I have taken one array of size, I don't know, 4, and then 4, 8, and 2, 10. Okay, so array of size 10. And if we have been asked what is the length of longest consecutive sequence of this sequence of elements present in this array, you can see my number can start with 0 and it goes 1, 2, 3, and 4 also present, 5 also, 6 also, 7 also, 8 also, 9 also. All these elements are present in this array, and if all these elements are present in this array, and if you pick up the elements, you can see the adjacent elements holds the difference of values exactly equal to 1, and this is we are long length of longest sequence. I don't think I think 9 is not present over here, like from 0 to 8. So length of longest sequence is coming out to be 9, and this is our answer. You can sort the array in O of n log n time, but we must have to find O of n solution. Okay, so I'm not going to consider this. So what should be of O of n solution? Okay, so let's talk about O of n solution. So let me first erase this all this stuffs, then we will talk it about. Okay, so we can build up O of n solution, like why not to store all the elements? I'm talking about store all the elements in unordered set. I hope you guys are aware about what this unordered set do. It will just put all the distinct elements from this array into a set, and set basically means the holding distinct elements, and it is being like unordered, and the cost of doing such operation for every element is like O of 1. So we have we have O of n time for pushing all the elements into an unordered set. Okay. Now, how we can find the length of longest consecutive subsequence? Subsequence, I should not have to say longest consecutive sequence of the numbers. Okay. So let's say if I push all the elements into another set, only the distinct elements comes. You can see there are two zeros present over here. I am not going to consider these two zeros. Okay. So like let's start with some number. Okay, if I will what now I'm talking about the approach to solve this problem. Okay, so I recommend my viewers to notice what I am going to say about. Okay, so let's say we have to pick up an element 3 from this number. Okay, so from this nums array. So I will check if there exists another number that is whose difference is like one more, exactly one more than this one, that is 4, and I will take another number whose difference is like this one, 2. First, let's us say nums of I is exactly equal to 3. I'll pick this 3 and check it out. If nums of I minus 1, that is nums of I, that is the value minus 1, if this value is existing in this unordered set, then I am not going to continue my iteration with this one, because this 3 is exactly in between, or exactly, that is the length of longest consecutive sequence starts before 3. That is, if nums of I minus 1 exist, that is I am talking about 3, and if nums of I minus 1 exist, that is 2 exist, then 3 is obviously not the start of the sequence. Okay, so 2 is going to be the start of the sequence. So if whenever I found such case, that is nums of I is already existing in my set, and nums of I minus 1, value minus 1, is also existing in my set, I'm not going to continue my iteration with this one. Okay, so what about nums of I plus 1? That is, let's say if this does not exist, that is nums of I minus 1, this value is not existing in this set. It means that we can start our length of longest consecutive sequence from 3, right? So we can start my sequence from 3. So what I'm going to do is I will start my nums of I with 3, and I will check consecutive values, consecutive next values, that is 3, then 4, and then 5, then 6, all these values in this set, whether the next values is going to exist in the set or not. Like I will check every time, that is whenever nums of I minus 1 does not exist, it means that 3 is the start of the sequence, that is the nums of I is the start of the sequence. I will check from this value, that is 3, 4, 5, 6, up to so on, I don't know. Like when certain element comes up and this element is not existing in the set, let's say 3, 4, 5, 6, all these elements are going to exist in this unordered set. It means that we have the length of longest consecutive sequence is now coming as 4. And let's say 7, when we check for 7, 7 is not going to be present in this unordered set. It means that our iteration stops up to this point, 3, 4, 5, 6, and this is our length of longest consecutive sequence. Okay, and whenever the my new element comes, I will check it for, if it does not exist in the set, I will stop my iteration at that point for a particular nums of I. And the very common doubt, why this algorithm runs in linear time. Okay, so I will explain this. Let us once check back the code, then I will explain this, how, why, that is the reason behind the linear time, running time of this algorithm. Okay, so let's move further. So let me just open up the submissions tab. Okay, you can see I have a lot of, like, first I will got a time limit exceeded because of a little mistake, that is I have just not taken care for that. Then I have got accepted, but you can see the runtime is very much washed. Then I have tried to optimize my code with the help of disjoint set union, that I am going to now discuss after this approach. Then it will give us a wrong answer because again I have missed one small test case, that is the base case, and then I got accepted with the help of concept of disjoint set union. It costed me 252 ms. Then I further optimized my code, then I again got 100 ms, then again optimizing, then it cost 92 ms finally. Now I'm going to talk about first this one, because most of the coders have implemented this solution, I think. What I've done is taken an unordered set, as I've already said. If you're not aware of that, Go and search on the internet. You will find a lot of resources for this, and go and study for that, and then come back to this video. I've now iterated in the entire nums and inserted into my unordered set. It will basically store the distinct elements without any ordering of the numbers. And my answer is now 0, and I will start iterating for this one, nums of dot size. And what is my current element? Current element is current next element, nums of I plus 1, that is current value plus 1. This is my j. I will check if this value exists in my unordered set or not. And what is that value? Nums of I minus 1. And what is the reason behind for checking this element? The reason behind is very much simple. If at any point of this sequence, like we have a sequence of 3, 4, 5, 6. Now let us say if I am checking for this 4 and 3 already exists, it means that my sequence must start with this one. So I will only check for this case, like whenever 3 encounters, then I will check for 3, 4, 5, 6. I will not check by starting with this 4, because this is not going to contribute us in the length of longest consecutive sequence. Okay, so that's why I started with 3 only whenever I will find the value equal to 3, and I will continue. Otherwise, it means that nums of I minus 1 does not exist in my vector. I will just check it out my next element until unless when this iteration stops. That is, we are not going to find any element. Then increment our j unto that is up to that point. And what is my answer maximum for the current step? J minus nums of I. And now this algorithm works in linear time, because you can see this condition while h dot count j exists j plus plus. It means that it will consider all these elements 3, 4, 5, 6 if we are talking about the consecutive sequence. And whenever this next 4 comes, it will not start iterating for the next element, that is 4, 5, 6. And whenever 5 comes, it will not start iterating for the rest of element. It will only start when it comes for the 3, because 3 is the start point of this consecutive sequence. Okay, so this is the reason why this algorithm, this code, this solution runs in linear time. Okay, so now I'm going to talk about the disjoint set union based approach. So let's move further. All right, guys. So I'm talking about the disjoint set based union approach, and the thinking that is the basic idea of such approach is like suppose we have the set of elements like 3, 4, 5, 6, and we have some elements too also. Like I will store all these elements, all these consecutive elements in a particular connected component. That is, if you think this problem in terms of graph theory or in terms of some connected components, like 2 is, suppose 2 is one element, and what is my next element? 3. And if 3 also exists in my this vector, then I will just store this that is 2 and 3 into one set. That is, I will perform the union set operation. Okay, that's why I've recommended you that if you are not aware about a disjoint set union, I will strictly recommend to go and look over the tutorials, look over the editorials, or you can say the tutorials, I don't know, that go and study over there and then come back to this video. Then you will understand this approach much better. Okay, and suppose 2 and 3 have the difference one, I will put this into one set. And suppose new element comes 4, 4 also holds a difference with this 3, which is 1. So I will extend this set to 3 to 4 also. So what I'm going to do is extend this set to this 4. And suppose another element comes over here 1, so I will also extend this set to this 1 also. And then suppose 6 comes, 7 comes, 8 comes, this is in one set. And finally, what we have to find? We have to find what is the largest number of elements present in any of the set. Like suppose 2, 3, 4, 5, 6 is one of the set. That is where every element, every consecutive element 2, 3 and 3, 4, 4, 5 and 5, 6 have the difference exactly equal to 1. And what is the number of elements present in this set? It is exactly equal to 5. And what is the number of elements present in this set? 3. And similarly in this set 4. So we have to just connect the elements which holds the difference of another element with exactly equal to 1. And how we are going to do that? And here comes the very much tricky thing. And what is that tricky thing? We need to understand this in very efficient way. Okay, so let's look over the constraints again. You can see this nums of I is again 10 power 9 and again minus 10 power 9. We cannot maintain a vector even of 10 power 9 size. So what I'm going to do is I'm going to map characters. that is map numbers to a specific unique key, because maximum numbers can go up to 10 power 5. So if let's say I have this 0, I will give it some unique index 0, then I will have 3, I will give its unique index, unique identification, you can also say 1, then I will 7, I will give its unique identification 2, and then 2, I will give its unique identification 3, then 5, then 4, and there is 5 also, 6 also, 7 also, but here comes 0 again. I have already given the unique identification of 0 as 0, so I will skip this, then I will give the unique identification for this one, and it comes out to be 8, I think. Yeah, 8 I think. Okay, I don't know. But you can see I have given the unique identification to every distinct element. Okay. So the reason behind is simple. Like there are total 10 power 5 elements. So at most we have a 10 power 5 distinct elements, and num suffice is like 10 power 9. We cannot maintain a 10 power 9 size. Okay. Now we have some elements, that is some unique key elements. What I'm going to do is, suppose we have get 3 element, that is number 3. Okay, now again I have get some, let's say I have get some 4. Okay, so I have gotten some another element 4 and get some another element 3. What is the unique ID of this 3? 1. What is the unique ID of this 4? It is, let's say, 6. Okay, so I will just connect this 1 and 6 into a one set, that is I will perform the union set operation on this 1 and on this 6. I will combine this, and similarly it goes on. Suppose a new element comes out to be 5, I will just pick up the 5's unique key identification, and I will just unite this set with the already present set of 3 and 4. Okay, after doing all the such operations, what is our answer? That is number of elements, maximum number of elements present in any of the set. This is our answer. Okay, now the what we have to do is just to perform a disjoint set union and write the disjoint set union based code. Okay, so let's look over the code. I think I should talk about 92 ms code. Okay, I will close all the other tabs. You can see all the test cases are passed. Now let's talk about this one. Okay, now I should have to talk about this one first. That is find set and union set approach. If you're not aware about that, go and search on the internet. You will find a lot of resources in the CP algorithms also. You can find that. This is going to do the find set function. This is the find set function with the path compression technique that I have used, and this is the union set function with I've used the rank compression also. And to increment the size, that is let's say I'm talking about this case, like we have this 3 and 4 in one set, that is the difference is 1, and we have, let's say, 5 and 6 already present in one set, and now let's say my new element comes over 5, so I should have to unite this set. I should have to add the number of elements present in this set, uh, also present in this set, to another set. Okay, what is the number of elements? New number of elements, 2 plus 2 exactly equal to 4. This is what I'm going to do over here. Size of this x root plus equal to size of this y root. This is only a new term that I have introduced over here, and also size of this y root plus equal to size of this x root when this holds. Okay, and also this one you can easily understand once you are aware of this union set and find set operations. Okay, now comes the exact code. If num of I is empty, return 0. This is the base case that I should have to mention. Now int is 0. This is going to assign a unique key for every distinct element present in this nums vector. Now iterate in this nums vector, and if that that is my current element is already not assigned any key, I will assign the key, and this can be easily checked with the help of maintaining a unordered map int comma int assign every unique element a unique key. Okay, and this is going to like storing parent, and first element of this pair is like parent, and second element of this pair is going to store the rank of this size of the connected component. Okay, and here is another SZ vector which is going to store the size of the connected components for every connected component. That is what is the number of elements present in this connected component. Okay, so if you're not aware about that, no need to worry about. Go and search the find set and union set function of this disjoint set based union data structure. You will be acquainted with all this information. Okay, and I will also assign the default values. Now comes the main thing. Start iterating in nums and check it out. If my current element is it, and I will check if it plus 1 exists in my mapping or not. Index.count, check it out. If it exists, I will perform the union set, and if minus 1 also exists, I will perform the union set with minus 1. Note that I am passing the parameters index of it and index of it plus 1. That is the unique key that I have assigned, I will that is what is the unique key that is assigned to my current number and current plus one next number, and I will unite these two sets. Okay, and finally return the maximum size of the connected component, maximum number of elements present in any of the connected component. This is our answer, and this will give you all test cases passed. So if you have any doubts, do let me know in the comment section of the video, and I will ask the viewers to like this video, share this video, and to subscribe to our YouTube channel for latest updates. Thank you for watching this video.